Hello, my pre-calculus student. In this video, we are going to learn how to find the reference angles and use reference angle to find the trigonometric value. Let's begin with the definition of reference angle. If the angle theta is in standard position, which is the x-axis is the initial side and the terminal side have to rotate either counterclockwise in this example to get positive angle or rotate clockwise to get negative angle. The reference angle theta prime is an acute angle that formed by the terminal side and the x-axis. In this example, since the given angle theta is an acute angle already, therefore the reference angle theta prime is the same as the given angle theta. Now let's move on to the second example. In this case, the given angle theta is between 90 and 180 degrees. So the terminal side is on quadrant 2, and our reference angle theta prime formed by the terminal side and the x-axis, the negative side of the x-axis. So this is your acute angle theta prime right here. Let's move on to the third example. In this case, the given angle theta is between 180 and 270 degrees. So the terminal side of the angle theta is on quadrant 3. Therefore, the reference angle theta prime formed by the terminal side of the angle theta and the x-axis is this acute angle right here, theta prime. Let's move on to the last example. In this case, the given angle theta is between 270 degrees and 360 degrees. And the terminal side of the given angle theta is in quadrant 4. Therefore, the reference angle theta prime formed by the terminal side and the x-axis is this acute angle right here. Now let's begin with this example. We want you to find the reference angles of 300 degrees. I can see that it will belong to case number 4 right here, because 300 degrees is greater than 270 degrees but less than 360 degrees. So first, let's get a picture. So I'm going to sketch an angle. Actually, I want to sketch the angle theta, and it is 300 degrees. So let's start with the x-axis. So this is the initial side, 0 degree, and I'm going to get positive angle. So I'm going to go ahead and rotate counterclockwise. So I'm going to locate where my terminal side will be. This is 90, 180, 270. So 300 will be here, right? Next, I'm going to go ahead and sketch the line to represent the terminal side. And now I'm going to go ahead and sketch my angle. So this will be the angle theta equal 300 degrees. So now I have to locate my reference angle. My reference angle is formed by the terminal side of the given angle theta and the x-axis. So this acute angle will be my reference angle. So to find this acute angle, we call this is reference angle theta prime. You have to take 360 minus your given angle. So in this case, my acute angle will be 60 degrees. So therefore, the answer, reference angle theta prime is an acute angle which is 60 degrees. Okay, so now we know how to find the reference angle Let's go ahead and review the trigonometric function. So if we want to find trigonometric function of any angle theta in standard position with the given points x, y, so this is the order pair and the terminal side of the angle theta. But here, to be convenient, we are going to sketch a right triangle. It's in quadrant 1, which is our x and our y value will be positive numbers, and the hypotenuse we want it to be 1, so to be more easy. So sine of the angle theta, and again, since the angle theta is in quadrant 1, it's an acute angle, the reference angle will be the same. Okay, so sine of the angle theta is opposite divided by hypotenuse. So opposite, which is y, the hypotenuse, which is the number 1. So just y divided by 1, or you just say y. So the reciprocal of sine be called cosecant. So cosecant, you just need to flip the ratio of sine to be 1 over y. Move on, cosine of the angle theta is adjacent divided by hypotenuse, so x divided by 1. Secant, reciprocal of cosine be 1 divided by x. Tangent of the angle theta is opposite divided by adjacent, so be y divided by x. Cotangent, it will be the reciprocal of tangent, so you flip it to be x divided by y. So everything is just reviewed. Now let's move on. If you know the side length, opposite with the three special angles, 30 degree, 45, and 60 degree angles, in a right triangle with the hypotenuse is 1. So here we are. We give you the two right triangle. The first right triangle, which is the 45 degrees. So this is the isosceles right triangle. So since the two base angles, they are equal, it means that the two legs or the adjacent and the hypotenuse must be the same length. So in this case, they are square root of 2 over 2. And let's find sine of 45 degrees. So sine opposite divided by hypotenuse. When you divide by 1, it just stays the same. So it means that it's just your opposites or your y. So in this case, it's square root of 2 over 2. Cosine adjacent divided by hypotenuse. Again, it's very convenient if your hypotenuse is 1, because when you divide by 1, the number stays the same. Tangent opposite divided by adjacent. The same number divided by itself is cancel out or it divides itself, so your quotient, your answer is just 1. Now let's move on to the second triangle. This is 30, 60, 90. Next, if I look at 30 degrees, my opposite could be 1/2. So sine be opposite divided by hypotenuse. Again, the hypotenuse is 1, so it means that you can ignore this because when you divide by 1, the quotient is the same or the answer is the same. So just 1/2. Your cosine of 30 degrees be adjacent divided by hypotenuse, so be just square root of 3 over 2. Basically just the adjacent. Tangent, this one requires some work here. Tangent is opposite divided by adjacent. So put square root, 1/2 divide by, so I'm going to divide the two fractions, square root of 3 over 2. Now when you divide the two fractions, you will keep the first fraction the same. You will multiply by the reciprocal of the second fraction. So now you can see that after I multiply by the reciprocal, you can see that I'm going to go ahead and divide 2 out, so 2 is gone. So my answer is 1 over square root of 3. But since you have square root of 3 in the denominator, you are going to flip. You are going to do one more step, which is called rationalize the denominator. So you multiply square root of 3 both, so you end up with square root of 3 over 3. Okay, let's move on to 60 degree angle. Now, if we look at 60 degree angle, then this side now becomes the opposite, because it's opposite with the 60 degree. So you have to be very careful of what angle you're looking at. And the opposite of 30 now become adjacent with 60 degree. Okay, so for 60 degree, side be opposite divide by hypotenuse. Your hypotenuse is 1, it's very convenient, so basically it's just the opposite, so square root of 3 over 2. Your cosine adjacent divided by hypotenuse. Now what have you noted about sine of 30 and cosine of 60? They exact the same answer. So the theorem say that if the two angles they are supplementary angle, then sine of one of those angles will equal cosine of the other angle. Okay, look at the next one. You can see that sine 60 will be the same thing as cosine of 30. Okay, so let's move on to tangent. Tangent of 60 degree be opposite divided by adjacent, so be square root of 3 over 2 divide by 1/2. Now when you divide two fractions, again you have to do a little bit more work because you need to simplify. So you keep the first fraction the same. You multiply by the reciprocal of the second fraction and try to simplify as much as you can. So in this case the 2 is gone. So now I get enough with square root of 3. If you have square root on your numerator, you don't have to do the rational line in the denominator. You stop. Okay, so now we found all the answer, right? We found the sine, cosine, and tangent of 45 degrees. We found the sine, cosine, and tangent of 30 degrees. And we also found the sine, cosine, and tangent of 60 degrees. Now we're going to use this answer to find the trigonometric value of the angles that's not acute angle. So let's start with example 8. Now we want you to find cosine of 120 degrees. So first let's go ahead and sketch the angle. So this is the initial side, 0 degree. Now you need to rotate it counterclockwise to get 120 degrees. So this will be 90. So 120. So I'm going to go ahead and sketch the terminal side. So this is 120 degree angle. So now the terminal side is in quadrant 2. So therefore the reference angle is the angle that make up by that formed by the terminal side and the axis. So this is my reference angle. So to find that reference angle, I'm going to say right here the reference angle, I will take 180 minus 120 degree. So that will be a 60 degree. So therefore we can make a note right here. Cosine of 120 will be equal negative cosine of 60 degrees. Why we put the negative sign? Because since we are in quadrant number 2, and you think about in your quadrant 2, your x, so again look at here, in quadrant number 1, your x is positive, your y is positive. So x, y. In quadrant number 2, your x will be negative, your y is positive. So you think about in quadrant number 2, since my cosine is if I look at my right triangle right here, my cosine of 60 degrees, and it in quadrant number 2, so that will be my x, which is the adjacent. So I'm just go ahead and just a sketch of a small triangle in quadrant number 2 for you. So quadrant 2. So this is the 60 degree. Yes. So this will be your x right here, which is a negative. So that's why your cosine have to be negative, because this is your adjacent and your hypotenuse is 1. So think about this. So therefore cosine 60, now we only know cosine 60 is 1/2. So basically now we just put that answer next to the negative side, negative 1/2. Now let's move on to tangent 210 degrees. So the first thing we are going to do is that we need to get the angle 210 degrees first. So you start with your initial side 0 degree. Then you are going to rotate this counterclockwise. So 0 degree, 90, 180, to 210 degrees. So this will be my terminal side. So this angle is the angle theta 210 degrees. So now your reference angle theta prime will be this angle right here. It's formed by the terminal and the x-axis. So in this case, since your reference angles is in or your terminal side of the angle theta is in quadrant 3, so your reference angle theta prime is equal, you take 210, the given angle, minus 180. And that will give me 30 degrees. Now in case if you say why we have to do that, do you remember we show you the note at the beginning, you see? So if the terminal side of the given angle theta is in quadrant 3, or the given angle is between 180 to 270 degrees, you would take the given angle minus 180 degrees. So that's what we're doing here. Okay, so now I have my reference angle is 30 degrees. So 210 degrees. So now think about if we are in quadrant number 3. So quadrant 1, quadrant 2, quadrant 3, my x is negative and my y is also negative. So if I go ahead and just a sketch of a triangle in quadrant number 3 for you. Okay, so you can see right here that your x is negative and your y is also negative. So tangent, you can think about tangent of this acute angle. So again, the reference angle is always give you positive answer for all the trig functions. The sine, what I'm doing right here, the sine, I just have to think, do I need to insert negative sine or not? Okay, so tangent is opposite divided by adjacent, but since opposite adjacent they're both negative, so the sine, when you divide two negative, the sine will become positive. So it means I don't have to put the negative sign. So I'll just put right here, this will be the same as tangent of the reference angle or the acute angle 30 degrees. And tangent of 30 degrees, we found the answer already. So these could be the answer that we'll go back and use it all the time. So tangent of 30 degrees, we find square root of 3 over 3, so the answer is square root of 3 over 3. So just let's write out the summary. In this video, we learned how to find the reference angle. We learned it. How to find the reference angle. And use the reference angle to find the trigonometric value. Thank you so much for watching this video. We will see you in class. Goodbye.